Mathematics 5, Revised K-12 Curriculum, Lesson Exemplar Based. Quarter 2, Week 6, Lesson 6. Our topic is about divisibility rules for 2, 5, and 10. Our focused learning competency is to use divisibility rules to find common factors of numbers. Explain divisibility rules for 2, 5, and 10. For our review, perform the indicated operation. Use long division method. Letter A, we have 452 divided by 2. Letter B, 612 divided by 3. Letter C, 1065 divided by 5. Letter D, 972 divided by 9. Letter E, 2150 divided by 10. Now let's think about it. Do you think there is an easier way to determine whether the given examples can be exactly divided by their corresponding divisors without performing the long division process? The usual way to determine if a number is divisible by another is to perform the operation. However, mathematicians have established some divisibility rules that can help us determine whether a number can be exactly divided by another number. Since the quotient leaves no remainder, we can say that the dividend is divisible by the divisor. Take note that only when there is no remainder that we can tell that the dividend or the number that is being divided is divisible by a certain number or the divisor. In example number 1, since 2 divides 452 without leaving any remainder, we can say that 452 is divisible by 2. A number is a factor of another number if it divides that number without leaving a remainder. Since 2 divides 452 without leaving any remainder, we can say that 2 is a factor of 452. A number is a common factor of 2 or more numbers if it divides the numbers without leaving a remainder. On the other hand, if a number is divisible by another number, then it is a multiple of that number. Going back to example number 1, since 452 is divisible by 2, then we can say that 452 is a multiple of 2. Subtopic 1, applying divisibility rules to determine if a number is divisible by 2, 5, and 10 by observing the number's last digit. We have 4 packs of candies. The first pack contains 10 candies. The second pack contains 15 candies. The third pack contains 12 candies. And the last pack contains 20 candies. We are going to divide the candies inside each pack and see if it will be divided equally into these 2 jars or if there will be any excess. Suppose we are going to increase the number of jars to 5. Let us see if the candies contained in each pack can be divided equally among the 5 jars or if there will be an excess. And now lastly, let us increase our number of jars to 10. Again, let us try to divide the number of candies from each pack and see if it will be divided equally among the 10 jars or if there will be any excess. From the activity, we can generate the following summary. So for the number of jars, we have 2, we have 5, and 10. Number of candies that can be equally divided. For 2 jars, we can only equally divide the number of candies with 10, 12, and 20. For the pack containing 15 candies, there are excess candies. And for the 5 jars, we can divide the packs containing 10 candies, 15 candies, and 20 candies equally. However, The pack containing 12 candies only cannot be divided equally because there will be 2 candies excess. For 10 jars, the pack of candies that can be divided equally are the pack containing 10 candies and 20 candies. Packs containing 12 candies and 15 candies cannot be divided equally, since for 12 there will be an excess of 2 and for 15 there will be an excess of 5 candies. By observing the last digits of that number that can be divided by 2, 5, and 10, we can generate the following. Divisibility rule for 2. A number is divisible by 2 if it is even or if the last digit ends with 0, 2, 4, 6, or 8. In the activity, since the last digit of 10 is 0, then it is divisible by 2. We can notice that the last digit of 15 is 5, which is not an even number. Therefore, 15 is not divisible by 2. Since 10, 12, and 20 can be divided by 2, then 2 is a common factor of 10, 12, and 20. Examples of numbers that can be divided by 2 are 540 since it ends with 0, 862 since it ends with 2, 1534 since the last digit is 4, and 5468 because the last digit is 8. So right away, we can tell that those numbers are divisible by 2 just by looking at the last digit of those numbers. Next, we have the divisibility rule for 5. A number is divisible by 5 if the last digit of the number is 5 or 0. In the activity, since the last digit of 15 is 5, then it is divisible by 5. We can see that 12 is not divisible by 5 since its last digit is neither 5 nor 0. Since 10, 15, and 20 can be divided by 5, then 5 is a common factor of 10, 15, and 20. Examples of numbers that can be divided by 5 or they are divisible by 5 are 645 because the last digit is 5, 780 since the last digit is 0, 1435, and 3920. Now let's have divisibility rules for 10. A number is divisible by 10 if the last digit of the number is 0. In the activity, since the last digit of 20 is 0, then it is divisible by 10. We can observe that 15 is not divisible by 10 since its last digit is not 0. Since the last digit of 15 is 5 and not 0, then it is not divisible by 10. Since 10 and 20 can be divided by 10, then 10 is a common factor of 10 and 20. Another examples of numbers that are divisible by 10 are 670, 940, 3000, and 6520. All of them ends with 0, and therefore they are divisible by 10. Now for our worked example, determine whether the following numbers are divisible by 2, 5, or 10 using their divisibility rules. More than one rule may apply. Example number 1, 462. So solution, 462 ends in 2, which is even. Then 462 is divisible by 2. 580 ends in 0, which is even. Then 580 is divisible by 2, 5, and 10. 898, we have also 1205, and number 5, 11,300. Now let's try to determine which numbers can divide the 3. For our solution in 898, it ends in 8, which is even. then 898 is divisible by 2. 1205 ends in 5, then 1205 is divisible by 5 only. It's not divisible by 2 because 5 is not even. It's not also divisible by 10 because it doesn't end with 0. So only 5 can divide 1205. For number 5, 11,300 ends in 0. Then 11,300 is divisible by 2, 5, and 10. Now for your activity, put a number on the line to make the given number divisible by the numbers inside the parentheses. So you can put any number in this line in order for this number to be divisible by this number inside the parentheses. Next, identify the common factors of the given numbers using the divisibility rules for 2, 5, and 10. Encircle all the number that applies on each row that corresponds to each item. So for example, numbers 480 and 390 can be divided by 2, 5, and 10. So therefore, the common factors are 2, 5, and 10. Then you proceed with number 1, 2, 5. Good luck! Thank you for watching Your Guide Towards Learning, Teacher ITV. Please like, subscribe, and share, and hit the notification bell to keep updated. Thank you!